And we are live. Hello, good morning, everyone. Thank you very much for joining us again for yet another Azure Weekly webinar topic. Our topic for today is modernizing your apps for the cloud. As usual, I'm your host, Herns Hermida. I'm the Cloud and Enterprise Business Lead for Microsoft Philippines. So today we're going to be talking about specifically what are the different approaches and what are the different platforms within Azure that you can use to modernize your current applications or build new applications in the future. So, applications fuel digital transformation. So, in the Microsoft book, digital transformation includes four pillars. How do you use innovative applications to engage your customers better, transform your products, and create more new and innovative products? How do you optimize your operations, and how do you further empower your employees to service your customers and your partners better? So a large part of the digital transformation efforts of every organization is to build new applications, but also modernize existing applications that are already doing operations, product transformation, or delivering products, and also applications that are engaging customers. Now, it's also important for us to note that a modernization strategy drives innovation and growth. It's simply going to the cloud through modernization, or going through modernization by bringing applications to the cloud reduces your administration significantly. You can get applications like websites running in minutes. You can improve your data analysis because you now have the ability to store more data from multiple sources in cloud sources cheaper and way better. And we have seen that organizations that harness the cloud, data, and AI outperform by peers to sometimes to the extent of doubling their operating margins. But in reality, when you take a look at all the applications that you currently have or the applications that you have planned in your pipeline to fuel your digital transformation or to take you to the next step of digital transformation, there are so many there are essentially so many questions that your existing developers or your existing technologies have in mind. Some of them include questions on how to ensure existing applications can take advantage of cloud capabilities. How do you get started because you have so many apps to start with? How do you need to start from scratch or rebuild for the cloud? So essentially, the topic for today is answering both these questions. How do you take an approach of using existing applications to maximize the cloud capabilities that exist on Azure, for example, and how do you build or from scratch or build applications from scratch so that they can take advantage of the cloud. Now, whenever we list down all the applications that you currently have in your inventory, you would have to make certain decisions on what to do for certain applications. So for example, some applications you just simply want to rehost it. It means you rehost it or redeploy it as a cloud. If the immediate business driver or the benefit that you want to get is to reduce your capex and to free data center space and to also get quick cloud ROI, then therefore you just rehost it in IaaS components such as virtual machine storage and networking. So the business results usually is that by lifting and shifting applications from their current on-premise hosting environment to a different hosting environment on the cloud using virtual machines and cloud-based storage and networking would immediately reduce your ROI and increase your ROI, not reduce, increase your ROI, and also reduce your data center footprint. Now, sometimes some of these applications, once it's already on the cloud, or you may want to make this decision while it is on premise, is to refactor the application. This means that you may want this means it's making alternate alters or making changes to the application to take advantage of the cloud scalability, which is, for example, unlocking the capability to do faster and smaller updates, code portability, and also creating greater cloud efficiency. So this would include the usage of containers and platform as a service components. Sometimes applications also need to be re-architected, which means that you really have to materially alter or decompose the applications from monolithic into smaller chunks so that you can increase your app scalability and agility. You can easily adopt the new cloud capabilities and technologies, and also you can mix technology stacks. And Re-architecting also, the next step of re-architecting is essentially rebuilding your existing application, throwing away the existing code and rebuilding your applications from scratch or creating applications that are new. So this would give us an opportunity to create new code or new applications using the cloud native approach to accelerate your innovation, to build your apps faster, and to also reduce your operational costs. Now you will find that the cost of running applications actually goes lower if you move from left to right. So this is the reason why a lot of organizations and a lot of companies may take the first steps of rehosting the application first by putting it on virtual machines, but eventually they would want to modernize these applications into using cloud native capabilities, such as using PaaS, serverless, and microservices components. And we already have evidence of a lot of customers saving a lot of costs and making their usage of cloud more cost efficient and much faster and and in a more optimal manner once you move to PaaS services, serverless, and microservices. In these different paths, as you can see here in this slide, the objectives would be different. So let's concentrate, for example, let's concentrate for the moment, because this is the theme of this webinar, on PaaS, serverless, and containers. Usually, when you rehost applications from on-premise to virtual machines or IaaS components in the cloud, this is usually the first step. We should be aware though that something called VM sprawl can happen very quickly. It can get out of hand if we have too many VMs, too many virtual machines in the cloud. Although we do have monitoring and governance tools that can help you manage VM sprawl. But anyway, let me just mention a couple of examples here. You can, for example, if you use PaaS or serverless components through re-architecting or rebuilding, you can easily integrate with other web and cloud apps. You can also unlock your business agility and continuous innovation if you refactor your application using PaaS and containers. So this is how you read this table. If you get a recording of this webinar, which you will, by the way, in about 24 or 48 hours from now, you will get an email from Microsoft to access the URL of the recording of this webinar, so you can listen to this webinar at any time using a device with an internet connection. Anyway, I digress. But once you get the recording of this webinar, you can actually pause during the middle of these webinars. One of the slides that you may want to pause is this particular slide so that you can see the objectives, different high-level objectives across refactoring, re-architecting, rebuilding, or rehosting applications. Now, let's take a look at serverless. What is the meaning of serverless? What do we mean by serverless? Serverless literally means you're not using a server. So it is this is the antithesis or the reverse of hosting applications in a virtual machine, which is essentially a virtual server running on Windows or Linux on a cloud like Azure. Serverless computing, on the other hand, is a cloud computing execution model when Azure dynamically manages the allocation of machine resources depending on a number of factors, including the scalability requirements of the said application. It also includes the components of the said application, the type of code. So essentially, it is the cloud provider like Microsoft Azure that worries about the sizes or the configuration or the optimization of the servers behind it that's running your code. You don't have to worry about that, because in a virtual machine environment, you'd have to figure out and still continue to do the sizing of such applications. So as you can continue to read, server management and capacity planning decisions are completely hidden from you as a developer or an operator, and you pay as you use. And that's based on the actual amount of resources consumed by an application. So this unlocks three basic benefits. One is that it allows you to solve business problems and not technology problems. You focus more on developing the code or the application that would solve a particular business problem rather than spending time figuring out the plumbing, so to speak, and figuring out the infrastructure that's required to run your application. It is also more efficient because it allows you to do shorter time to market, because essentially you're deploying code on a platform or a set of platforms in Azure that's already ready to run the code. You don't need to set anything. Practically, you don't need to set up a lot of stuff. It also allows you to be more flexible because it allows you to pivot between different approaches. As you can see later on, you can may start with, let's say, web app services, and then you can move on to microservices, and then other serverless technologies that are available. So that flexibility would allow that easy way to pivot across different platforms will allow you to be more flexible. All right. Now, there are different Azure serverless technologies wherein, remember, the focus is on the apps and not the infrastructure. The focus, therefore, shifts from you worrying about how much resources is required to run the application to what is really required to help the business in terms of making the application work for the business. So there are a number of components, and we will give you an overview in this webinar across each one. We have a fully managed platform for cloud applications called App Service, a serverless architecture called Functions. We have fully managed integration services and flow services using something called Logic Apps. And then we also have a fully managed container orchestration service called the Azure Kubernetes Service, or AKS. Okay, so we'll spend the rest of the time in this webinar to talk on each one. Now, before we delve into each of these serverless technologies on Azure, let's talk about what DevOps is first. So if you don't know what DevOps is essentially an approach wherein you start creating an application. First of all, you have to plan and track the application first, develop the application, build and test it, deploy it, and then operate it. And while it is operating, you are monitoring the performance and the application and learning from how the users are actually using your applications, which then gets fed back into the next iteration or improvements in the application that you would like to make. So, for example, if you have a mobile application that you deployed on Azure and then users are continuing to access that application, you're discovering that there are certain parts of the applications where users seem to have a hard time going through because there's something wrong with the code. So that feedback is sent back to the plan and tracking stage so that in the next release of the said mobile application, you can continuously deliver improvements. That's essentially what DevOps is. All right, so that's important because we'll be mentioning DevOps for a lot of scenarios in the next subsequent slide. So let's start with the Azure App Service first. The App Service is a platform where you can quickly build, deploy, and scale powerful cloud applications without worrying the infrastructure. So it accelerates application development using your existing language skills. It supports a large number of programming development tools that you are already familiar with. It is a fully managed service. So like I said before, it is an approach of letting you focus on the application logic and let Azure and Microsoft worry about the mundane tasks such as maintaining the servers, installing OS patches, scaling, load balancing, and domain management. It is also enterprise scale because it has met all the rigorous performance, security, and compliance requirements, and you have a choice of hosting options. We have several customers who have already moved their applications to what was initially an IaaS-based approach on virtual machines with a full stack of application servers, web apps, web application servers, and database servers in various forms of virtual machine. So the thesis here and the approach here is to simply get the code, let's say it's a .NET code or a PHP code, and run it on the app service as code and not worrying about what is happening in the background. So as you can see here in the slide, we support .NET, Node.js, Java, Docker, PHP, Ruby, and Python. It's a fully managed service wherein Microsoft does the auto scaling and load balancing. So for example, if you created an application using, let's say, a combination of both PHP and Python, let's say it's a web-based application, you simply deploy the code in your favorite IDE, let's say it's Visual Studio, and then you configure Visual Studio to say that you're deploying this code on the Azure App Service. Of course, it assumes that you have a subscription on Azure for the Azure App Service and you configured those things in the Azure portal before you actually deployed your code. But what is happening is that in the background, Microsoft is taking care of everything from auto-scaling to patching to backup and recovery and so on. You also take advantage of the fact that App Service operates across all of our data centers across all 54 regions all over the world. You can split your code into multiple chunks, if you will, some of which are still continuing to run on-prem and some of them are running on Azure App Service. Our customers like the fact that App Service fully supports Active Directory integration, so you can get both authentications from internal users or external users using Active Directory, and then it's secure and compliant as well. So there are a number of app gallery images in the marketplace that you may want to start with if you don't know what to start. So if you have a Node.js applications and you don't know exactly how to structure your Node.js application to deploy on an app service, you can use the app gallery for some guidance on that. All right, so I'm not going to read through all of these service features and capabilities. I just want to put it out there in the slide so you can read through it offline. So if you're listening to this webinar on a recording, you may want to pause at this point and try to read through all of these detailed service features and capabilities. So it's a fully managed service. So anything that you deploy on an app service. So let's say it's a Java application that you deployed on the app service and you pinpointed to the app service and made it known that you're running a Java code on top of it. You can automatically plug in It is automatically integrated and plugged into a number of other Azure services. Active Directory, you can put in additional cognitive services. So for example, you created the chatbot using our bot framework. You can immediately integrate that to your said Java application because App Service has already built-in plugs into cognitive services, search, media services, DNS, and other services, or even database as a service. So a great example here may be, say you have a PHP application that you're running on App Service, and that PHP is actually talking to a MySQL database. We actually have an Azure Managed SQL database that we offer as a service. So it's the same approach. You don't have to install MySQL in a virtual machine anymore. You just simply have to take your MySQL data and run it on Azure MySQL, manage MySQL service. So your PHP application is still continuing to talk to your MySQL server, except that both of them are running on managed platforms. So here's a handy decision tree, if you will, for .NET applications. So this is just an example. So let's say if your app has a server or custom dependencies, if the answer is no, then you can use pure cloud services. So deploy your .NET application as Azure App Service. So it's as simple as going to your Visual Studio IDE and then deploy the new project as Azure App Service. If your app does have a server and custom dependencies, you want to do a quick migration process, then you just deploy it as a virtual machine. So it's no different from lifting your entire stack from on-premise virtual machines to virtual machines on Azure. So if you're not really in a hurry, you may want to use Docker or Windows containers. So you have three choices there: Windows containers on Azure VM, Windows containers on App Service, or running it as Windows containers on Service Fabric. So we're going to talk about Service Fabric a little bit later on. So here's an example of we have a lot of customers who actually use our app service for digital marketing websites and digital marketing mobile sites. So again, I'm just aligning some of the features that I have described about app service in terms of how you run it, of how a digital marketing website or mobile site can take advantage of it. So let me just mention a few things that I didn't mention a while ago. So the app service, for example, has already APIs that can easily connect you to authentication services from third parties, such as other popular social media networks. The other thing is that you can also engage users with rich media. So you can use, for example, our CDN services or media services to store and cache, respectively, your media content that you embed in your marketing website. So essentially, the approach is storing your media and media services and using our content deployment services to be able to deploy that media at scale without or little buffering. So that's an example. So from an architectural standpoint, this is kind of what it looks like. So as you can see, I want to point out that the centerpiece of this entire thing is the app service. So let's say you have a browser, a user connecting to a browser that connects to Azure Traffic Manager, which then makes a decision on how to route that traffic. So in front of your app service, which is running your digital marketing website, say it's running on PHP, for example. Um, it has a connection to the back end databases. So it can connect to Cosmos DB for non-SQL databases, for SQL database connection. So for example, you may have a SQL database that stores marketing content, or some customer databases. App Service already has a plugin connected for that. Now on top of that, you can also then use, for example, a monitoring service called Application Insights, because again, we're using DevOps approach here, that you continue to monitor the performance of the applications running the app service, so that you can continue to make any continuous improvement or deployment using tools such as Visual Studio or any other CI/CD or DevOps tools that you have available. Okay, so I would also mention that if, let's say, for example, your multi-channel marketing website is also using SendGrid as a service. This SendGrid is a third-party app, third-party software as a service provider whose job is to provide email marketing. You can also integrate those APIs into the same code that is currently running on the app service. Okay, so we talked about the app service. Let's now talk about containers. Now, remember, in the first few set of slides, you have a choice of what do you want to do with the code. So let's say you have an existing application, you decide to get the code and then run it on web service. If you can't afford to do that, or if you don't want to do that, one approach is containerizing your existing application. So now, which brings us to the definition of what really a container is. A container essentially is, as you can see here visually, what's the difference between a virtual machine and containers. The purpose of a virtual machine is to virtualize the hardware. So essentially, you have a single server, and using using the virtual machine, the underlying virtual machine software, or what we now call as hypervisor, you create multiple logical servers within the same physical server, and therefore maximizing the compute capacity of a particular hardware server. Containers, on the other hand, takes a different approach, somewhat similar but really different. In that it virtualizes the operating system. So the applications are used as units of scaling. So now that you know what a container is, let's talk about the benefits of using containers. Containers allows you to become more agile, because you can actually ship applications faster. It allows you to move workloads across different platforms, so it becomes more portable. You can achieve resource efficiency because you can actually pack more containers, more applications in more containers inside the physical server, rather than the number of virtual machines in a single physical hardware, assuming that you're deploying this on-prem. You can also achieve rapid scale. You can also use it across any operating system. The standard container platforms today, such as for example, I forgot the name right now, but it can run on any operating system, Linux or Windows. Docker, that's the name. Docker, you can run Dockerized containers on Windows and Linux. You can deploy it on premise on the cloud, and this is really one of the advantages that initially why people are so excited about containers and started deploying on containers. It's the ability and the agility to deploy applications as is, without any changes, by simply shifting your container from on-premises to the cloud and vice versa. You can use it on any app. It can be a monolithic application, can be a microservice-based application, and you can run any type of language application created on any type of language in a container. So the other container advantage is that here is the density. So here's an example of traditional virtualized environment. You can see that the utilization of the hardware is actually pretty small. But containerization of applications will actually give you the the density or higher density within a single hardware, or in a single virtual machine. So in a containerized environments, you can migrate containers and their dependencies to underutilized VMs and improve density and isolation. So I hope that you can see the difference between that. Because remember, the objective of a VM is to virtualize the hardware to create more servers, but within those virtual servers, there is underutilization. Containers, on the other hand, you can actually maximize the potential or the capacity of a virtual machine by simply putting in more containers within said virtual machine. By doing that, you can pack in more applications in a single piece of hardware if you were doing this on premise, and therefore you can there's cost efficiencies that are related there because containers are lighter weight and also fast scale dynamically. There's a lot of momentum on containers right now. So Gartner has said that very soon 50% of enterprise applications will run on containers. Um, the average size of a container deployment has grown 75% in a single year. So this is why if you're an IT professional, not a developer, you have to be aware that a lot of our developers are already wanting to deploy their applications on containers. So therefore, we have to learn how to manage them and how to orchestrate them. So larger companies are also leading adoption. So how do we manage containers and how do we support containers on Azure? So there are many ways you can actually, for example, deploy web apps or APIs using containers in a PaaS environment. So you can actually run containers within the app service. There is a set of services that's available in Azure that can run containers on Service Fabric. We'll discuss Service Fabric later. There's also a orchestration service called the Azure Kubernetes Service and a tool or a platform, if you will, to store the containers. This is called the Azure Container Instance, so that you can effectively burst your AKS clusters. I'll talk more about AKS clusters and AKS and things like that a little more later. I just wanted to set the tone on how we support containers within Azure. Okay. So you can also use a different partner solutions like the ones from Docker, ones from Red Hat OpenShift, which is turning out to be one of our more popular containerization management and orchestration platforms in Azure. This is Red Hat OpenShift and also Pivotal and a whole bunch of third-party tools such as Helm and Mesos. Now, if you have a preferred container platform such as Pivotal Cloud Foundry, Kubernetes, the open source Kubernetes, Docker Enterprise Edition, Red Hat OpenShift, or Mesosphere DCOS, you could bring that platform to Azure. So the whole point that I'm trying to make here is that if you already have a containerized set of applications that's running on any of these 5 platforms, you just simply run those platforms in Azure. A great example here is that if you're already using Red Hat OpenShift to run containerize and orchestrate containers within your on-premise cloud or in another cloud, for instance, you just simply run the same platform on Azure because Red Hat, along with Pivotal, open source Kubernetes, Docker Enterprise Edition, and Mesosphere are fully supported on Azure. So, if we don't know what orchestration is, well, let's tackle that now. Orchestration essentially means a number of things. One is scheduling. These are like the canonical operations of what orchestration means is. What does it mean? It means scheduling containers, monitoring the health of the containers, making sure that there's failover in case functions running in one container, and for some reason that container fails, a similar container running similar code would take over to so that the application logic doesn't break. Scaling, networking, service discovery, and coordinated upgrades, and also the underlying platform upgrades, etc. So those are the things that are part of orchestration. So as you can tell, if you all of those capabilities can actually be run are actually the purpose of why Kubernetes was invented. So open source Kubernetes, you can download it from GitHub or any of your other open source sources, if you will, run it on Azure on a virtual machine. You can have your own Kubernetes environment. But why do that? Why do that? Whereas we're in Azure, we actually have a service that's based on open source Kubernetes called Azure Kubernetes Service. So let's take a step back. Kubernetes is actually the industry leading orchestrator. So ask anybody and ask any open source full stack developer that is that are creating applications on container and ask them how are they orchestrating this. The answer is almost always they're doing Kubernetes. It can work across multiple clouds, public, private, or multi-cloud. It is actually modular, pluggable, hookable, and also compostable. It's also self-healing. Uh, so all of our friends in the open source world that have created this Kubernetes community has created a pretty solid platform to run and manage Kubernetes or manage containers. So let's talk about Kubernetes 101 first. So what does this mean? So let's take a piece of code. So in in an open source Kubernetes environment, users communicate with the API server and apply a desired state. There are also things called the master node. You don't create this, by the way. It's already part of the Kubernetes orchestration environment. They actively enforce the desired states on something called the worker nodes. This is where you come in and deploy your applications in the form of containers. So this is where your stuff is. So this is your code that you containerized. And once you've subjected it to the open source Kubernetes orchestration service, all these things such as kubelets, kubeproxy then comes in. So the whole job of the Kubernetes service is to orchestrate using the steps that I just mentioned in the previous slide. So making sure that containers are replicated, they can do self-healing, they can do failover, and so on and so forth. So we talked about DevOps a while ago. Kubernetes and DevOps work very well together because, as you can see, the objective of DevOps is continuous improvement and continuous development of an existing application, and you continue to improve that application based on feedback from the users. That's the same thing with AKS. So essentially, what this diagram is trying to tell us is that DevOps is the DevOps approach is embedded within the Azure Kubernetes Service environment, because that's essentially what Kubernetes is, allowing developers to create containerized applications within the DevOps frameworks. So how does manage Azure Kubernetes Service work? So how is it different from open source Kubernetes? So first of all, it exactly does the same thing as open source Kubernetes, except that it does everything that you see here on the left side. Okay, automated upgrades and patches, creating highly reliable and available containers, and so on. Okay, so Azure takes care of everything on the management control plane and all the things, and then it does the scheduling of the pods over the private tunnel. And the only thing that we need to do is just deploy your containers and let AKS manage the orchestration across that. So the other capabilities that Azure Kubernetes Service provides, other than the standard capabilities of open source Kubernetes, such as portability, extensibility, and self-healing, would include deploying and managing and monitoring Kubernetes with ease, allowing us to accelerate containerized app deployment, rolling out new features, which is the DevOps approach, securing environments with layers of applications, and also scaling applications on the fly. So you can see here in this particular table the differences between open source Kubernetes and managed Kubernetes on Azure. So things such as containerization, application iteration, CI/CD, cluster hosting, you'd have to set up all of that in open source Kubernetes, or essentially do that yourself. But in managed Kubernetes on Azure, or the Azure Kubernetes Service, things like cluster hosting, upgrade, patching, scaling, monitoring, and logging, we already do that for you. Um, the partially the partial task of containerization, application iteration, and continuous improvement and development is being done by managed Kubernetes on Azure as well, while some of them are actually being done by yourself. Okay, larger companies again are leading the adoption. It automatically follows that if an organization is deploying applications on container or as containers, they would need a container service. So therefore, the intensity at which customers are deploying containerized applications is directly proportional to the intensity of deploying Kubernetes, and likewise deploying Azure Kubernetes Service on Azure. So these are some of our customers who have deployed Azure Kubernetes to manage and orchestrate their containerized applications. I think I have an example here. Oh, sorry. Before I go to the example, this is how I don't want to go through the code because I don't have enough time, but you can see all of this in the Azure documentation and also on GitHub. So creating a cluster means in the old way means that you'd have to provision the network and the VM, you have to install dozens of system components, you have to create and install certificates and register the agent nodes within the control panel, all done in a command line like interface. I don't think there's a GUI there, so you'd have to do all of that. But remember, the underlying architecture and the platform that can do that for you is already there. The only thing is that you have to remember the code or the commands that does all of these for. In the Azure Kubernetes Service, you just simply say az aks create. If you want to upgrade the cluster in Azure Kubernetes Service, you just say az aks upgrade. While in the old way, you have to upgrade your master nodes. You have to be careful in doing that because if you want to do rolling upgrades, you want to make sure that you do it properly and then in the right sequence and so on. And then you also have to the term here is to cordon or drain upgrades the worker nodes individually. So that's what I mean by cluster upgrades. So you start with one node, upgrade that, then start with the next node, and so on and so forth. But in Azure Kubernetes Service, you just simply say az aks upgrade. If you want to scale a cluster, you have to do it manually. In the old way, you have to provision a new set of VMs, you have to install system components, and then register the nodes with the API server in the Kubernetes service. Whereas in AKS, you just simply enter az aks at scale. The other part of the Azure Kubernetes Service environment is that it allows you to put in layers of isolation. For example, you can control access through Azure Active Directory or role-based access control, and so consequently, role-based access control. There's Key Vault to safeguard your keys. You can secure your communications across the different nodes through VNet and policy, and you can also be ensured that your Kubernetes and your containers are actually running on a platform that's compliant with over 200 plus security and compliance standards such as SOC, HIPAA, and PCSI. Um, I think this was mentioned a while ago. There's also built-in auto scaling. You can definitely deploy your containers across all different regions across Azure if you want to, so take advantage of the global reach. You can elastically burst from AKA a cluster using Azure Container Instance, and you can also geo-replicate your container registry for low latency image serving. So here's an example is if your application is actually serving thousands of users across all over the world, you can spread your containers among multiple instances across multiple data centers for better scaling while you have a single AKS instance that orchestrates all of that. So what are some of the top scenarios for using Kubernetes on Azure? So an example is you containerize your applications and then lift and shift up to Azure and that you let AKS moderate all of that or orchestrate all of that. The advantage here is that you actually don't need to refactor your app that much because you just simply changed it from running on a virtual machine to a container. You can use AKS on microservices for greater agility. We have some examples of some machine learning capabilities created on R and Python that were deployed as containers. So therefore, you can increase the scale of how you do machine learning, and also for IoT. So one approach here is that the IoT logic that actually the IoT functions that actually either receive data from IoT devices or does the analytics out of the raw IoT data is deployed as containers and again orchestrated as Azure Kubernetes. So lift and shift to containers, this is kind of what it looks like. You can speed up your application deployments. You can defend against infrastructure failures. So your existing application, you convert that to containers using ACR, and then you now have your you may in the next steps, subsequent steps, you will now have a Kubernetes cluster with your modernized application as different containers accessing a cloud database. Microservices, won't talk a lot about this much because we're going to be covering that in a few minutes. But the whole point here is that once you've already broken down your monolithic applications into several microservices, you can deploy those microservices as containers as well. Data scientist in a box. So let's say you have, like I said a while ago, you have a AI model that was created using Azure Machine Learning Studio or Python or any other of our deep learning frameworks. Once you already have that model trained, you can put it in a container, and then that container can then be deployed on GPU-enabled VMs so that the continuous training of that model or the evaluation of data out of a trained model becomes faster, more scalable. So your AI and predictions and forecasts becomes much faster than before. Um, in an IoT scenario, AKS can help in creating portable code that you can run anywhere. So the essential benefits also here is for you to be able to become more elastic and scalable in terms of your IoT. So let's say you're getting raw data from multiple or thousands of IoT devices across the world. So one example of one customer using AKS for various applications is Maersk. So what they do here is they are using the business problem that they're trying to address here is to elevate their net satisfaction rating for from their customers. So what they want to do is they want to create a set of applications that follow workflow, a more efficient workflow, a faster workflow. And one of the technical issues is they want this application to work faster, execute faster, so that customers don't complain, and therefore their customer satisfaction will increase. At the same time, they want to spend less time on software management. They don't want to figure out the nuts and bolts in the pipeline or the plumbing behind running containerized applications and orchestrating them. They still want to do automation and continuous delivery and continuous improvement because they are a strong believer of DevOps. In fact, DevOps is deeply embedded within their developer environment. So these are some of the results of the example that I gave a while ago on containerizing applications and allowing Azure Kubernetes Service to orchestrate those and manage those containers. A reduction in provisioning time, cost savings, automation of production deployment, increased developer autonomy, and also spending less time in managing secrets, because this is a case wherein encryption keys are actually stored in something called Key Vault, working hand in hand with AS. Okay, I did say that we were going to talk about microservices. So let's talk about microservices. So a traditional monolithic application looks like this. So each of the colors here, the circles here, are think about it as components or logical components within a certain application. So in order to scale, the old way is to scale the same application several times across multiple physical or virtual machines. And then you can use some sort of load balancer to balance the loads across these applications. Microservices, on the other hand, requires that each of these application logic be split into multiple components, and then these components are then spread across multiple virtual machines or multiple environments of running. So whereas the monolithic approach takes the load balancing approach by saying that if a request comes in and the load balancer makes a decision on which virtual machine to bring it to, microservices is a different approach because you're not load balancing, but essentially you're assigning the said application request to the exact application logic that's supposed to do something about that request. So it can span across multiple VMs or it can span across multiple environments. You can also move services from one environment to the other if in case, for example, one of those environments fail. So these are the business benefits and developer benefits of creating applications in a microservices approach. So the business benefits is that you can get faster future releases. You can get greater visibility. You can easier attract. You can also use cutting edge technologies to create development skills. But for the developers as well, as you can see here on the right side, it also gives them greater agility through smaller teams, because not only you're not assigning application development one per application per team, but you're actually subdividing the application into multiple logical bits and then assigning those bits into multiple agile teams. Okay, you can easily perform schema updates and can simplify integration. Microservices are also driving digital innovation. So as you can see here, this is one of our partners in the market analytics space has determined that microservices architecture will soon become the standard, or have already become the standard. So you can see these are the market sizes of containers, app modernization, and microservices architecture. So you can see it's essentially a growing industry, and it's a growing approach. So what this slide is essentially telling us is that microservices will be the future. All starting, all, all of course, starting with the idea of running applications without worrying about servers. So there are certain stages in the journey. So if you have a traditional monolithic application, you can definitely run this monolithic application as a container. We spent a lot of time discussing that in the previous slides a while ago, a few minutes ago. So this is not lifting and shifting. You are simply refactoring the application and to make it run on a container. So you can also get your existing monolithic applications and then enhance the application through a new series of microservices that you have created from scratch. You can also then move on to the stage wherein you have parts of the existing monolithic application extracted, and then the final state would be a newly or transformed microservices apps wherein the traditional single or traditional monolithic application has now been broken down into multiple services. So now you might be sitting there wondering, okay, so once I've subdivided my application into multiple microservices, what is the environment that I run it on? So the answer there is Azure Service Fabric. So this is a service wherein we run multiple microservices. So these are some of the challenges or needs of developers when building microservices-based applications. So some of the usual challenges include we want to focus on business logic rather than microservice platform maintenance. We want to monitor and govern uh, at overarching and also at granular levels. We want to track multiple development pipelines, especially in a CI/CD DevOps environment. Where you have multiple teams creating a lot of things that are compartmentalized or broken down into multiple services. So you want to get a handle of that. You want to deal with complexity of interaction with network communications, or you don't want to deal with that anymore, I should say, and so on. So Service Fabric is essentially in Azure a microservices platform for business critical application. So you can see a common theme over here. Whereas in Azure Kubernetes Service, we take away the pain of managing the orchestration environment, or take away the pain of having you create an orchestration environment based on open source Kubernetes. We basically took the open source Kubernetes and run it for you as a service. So therefore, all you need to do is to create an instance of AKS and deploy your containers there. It's the same approach with Azure Fabric with microservices. You build, you deploy, and you operate. We have the same tenants, the same flexible infrastructure. We take care of the lifecycle management. We take care of 24/7 availability and performance. You can scale up your application. You can do security and compliance, and health and monitoring is also included. Azure Service Fabric can do both microservice and container orchestration should you want to combine both of those. And you can read through this slide later on if you're listening to this via a recording to eliminate all of these challenges. So one of the challenge that we mentioned a while ago is that you want to focus more on business logic instead of microservice platform maintenance. This is exactly what we are trying to do here. Um, you don't have enough time nor resources to manage the environment to run microservices. So therefore, this is the reason why Fabric exists. Service Fabric also powers a number of our Azure and Microsoft services. So this is the underlying fabric, if you will, that powers services such as Cosmos DB, Dynamics, Power BI, Skype, Microsoft Event Hub, Visual Studio Team Services, and so on and so forth. So these are all just a sampling of all the services that are running on top of Azure Service Fabric. Because these are either containerized or microservice based architectures as well. So this will give you peace of mind that this platform is actually well tested and well used. Now there are three modes where you can use where you can use Service Fabric. So one mode is Service Fabric Mesh. There is another mode called Azure Service Fabric where you can create dedicated Azure clusters, or you can do Service Fabric standalone where you bring in your own infrastructure and you just simply give you the building blocks of creating your own Service Fabric environment in an environment that you completely own. So as you can see here, the continuum. This is not in public preview, by the way. This is already released. But Service Fabric Mesh is a fully managed microservices platform that alludes to the vision that I mentioned a while ago of giving our customers a fully managed platform where you can run microservices. So you'd have to make a decision on which one you want to use based on the responsibility that you want to take on. So in terms of, let's say, in Service Fabric Mesh, the virtual machine, OS patching, runtime updates, capacity planning, and so on and so forth are being done by Azure. All you need to do is deploy your microservices apps on top of Service Fabric Mesh. How do you do that? Unfortunately, I don't have a screenshot here, but essentially it's the same thing as container services. So when you, for example, in your interactive development, in your IDE environment, in, let's say, in Visual Studio, when you deploy a project, you just simply select Azure Service Fabric, and then Visual Studio will take care of the rest for you. If you choose the Service Fabric cluster option, then cluster capacity, network storage, and app deployment is done by yourself. In the Service Fabric standalone option, hardware OS patching, runtime upgrades, cluster capacity is done all by yourself. So some of the top use cases of Azure Service Fabric includes migrating existing application assets to the cloud, um, B2B solutions on the cloud. IoT is also a pretty good or a pretty common use case for using Service Fabric. Creating new cloud native apps and also using the Service Fabric environment to create low latency apps which combines data and processing into a single set of microservices. Oh, sorry about that. So one of our customers that uses Service Fabric, not Mesh, but Service Fabric extensively uh, behind their website is Alaska Airlines. So they started their journey as anybody else, creating a monolithic, multi-stacked or full-stacked set of components for their website. So their web pages are being run by a layer of a web service layer. The application logic runs on an application server, and then the database runs on a database server, each of which are running in their own set of virtual machines. A very standard and very traditional approach. Then they containerize their applications by using Windows Server containers. They haven't brought their websites to Azure yet at this point. It's all running on Windows Server. So therefore, this is where they got their feet wet in terms of running applications as container. When they discovered Service Fabric, they now have a safe and consistent deployment strategy that maximizes their uptime. So now they use both the combination of containers and microservices running on Service Fabric to power their reservation systems, their booking systems on Alaska Airlines. So here's an example or some scenarios on how you would use them. So you would have the container registry, which contains all of the containerized application logic. Then you have the service fabric where you are actually running the different components of the other set of the applications as different with different capabilities. So the developers in this case were smart enough to name their microservices based on what it does. So for example, in this case, this is the thing that does um, the website logic of the hotel registration in this case, because this is a hotel registration site. And then you got another service or set of code that runs the application registration logic as well, that connects to the SQL database. So as you can see here, it's a completely different approach compared to running an application on a full server stack, because you don't see anything like application server, you don't see things such as a web server over here. It's all running on serverless. So we don't have time to discuss the other stuff in greater detail, but I just summarized this in one slide right here. Other serverless application platforms includes Azure Functions. So same approach, you manage the apps instead of the infrastructure. It scales on demand. So Azure Functions, think of it as a set of mini application servers which runs your application logic, which you may have created using different languages such as .NET, Java, or etc. So whereas in app service, you have a full set, you have your full web. So let's say, for example, you're using the app service to run a website. The full logic of your website, including the website rendering, the back-end processing, the back-end logic of the website is running as a single app service in web app service. The only difference with the traditional approach is that you don't have a server that runs all of that. It runs on the app service. If you want to take the same approach and run it as a set of functions, you can definitely do that. So you split up your web applications into multiple different functions, and then you deploy it on Azure Functions, and then you tie it up together with Azure Logic Apps, because this is where you create business process and workflows visually. If I'm not mistaken, the main tool where you create your business workflow is the workflow of the applications is either Visio or within the Azure portal. And if I'm not mistaken, because I don't have experience on it, you can also do the same thing on the Visual Studio IDE environment. So it's hard to describe this without a whiteboard, but essentially, let's say your website, you divide it across multiple functions and you let Azure function. So now you have a set of, let's say, 50 functions that does various things for the website. You have the logic apps then that ties all these functions together in the form of flows depending on certain conditions that are met while the customer is using the website. So using logic apps, you can also automate business processes, B2B, EDI. You can integrate with SaaS and enterprise applications and so on. The kind of the odd man out here is the event grid. So the event grid is literally an environment where it listens to millions of events per second in near real time using managed services at elastic scale. So it uses hyperscale telemetry ingestion that collects, transforms, and stores millions of events, and it also uses time-based event buffering. So a great use case of event grid, and what I've personally seen where event grid is used a lot is in IoT environments. So for example, let's say you have for the sake of discussion, let's say you have 100 factories, and each of these 100 factories have 1,000 IoT sensors that takes in telemetry every 5 seconds. Okay, so now you're dealing with 100 factories, 1,000 sensors, so 100 times 1,000, so you have 100,000 sensors, and then it is getting multiple events every 5 seconds. So if you do the math in your head, you can just imagine that the amount of telemetry that you need to listen to is numbers in the millions. So you cannot create a containerized application for that. Service Fabric definitely doesn't work for that. This is the reason why Event Grid is there. Event Grid essentially is a listener for all of these events that are happening at the same time. And then you can use it together with Logic Apps and Azure Functions or any other customized applications that may be deployed in a container or in a microservices environment and Service Fabric Mesh or Service Fabric that essentially triggers functions. So for example, if one of those sensors triggers a heat alarm because because it detected a component within a factory that's overheating, you can event grid is the one that's listening and it triggers a call to an Azure function that then probably send an audible alarm to a loudspeaker in the central office. Okay, so might sound like a wild imagination, but wild example, but that's one example that I can think of where you can use event. So for .NET applications, this is a table. This is just one of the many tables that's used to make decisions and recommendations on what to use for what. Depending on the type of application architecture that you currently have, you can use Azure Virtual Machines. So as you can see here, for web apps that are monolithic in nature, VMs definitely will work. The recommendation is to just simply move the monolithic application from away from VMs and run it as code in the Azure App Service. You can also deploy it as containers and have AKS monitor all of that, or you can get the code divided into multiple microservices and then use Azure Service Fabric to run to put all these services together. If it is a cloud native or microservices architecture based application, you definitely can see that it can't app service and VMs won't work for that. What's recommended is the putting it on containers and then running it as AKS, or definitely you can use Service Fabric for that because of the cloud native microservices nature. And then you can you can follow on that using the same logic to understand this table. So essentially now, we're almost at the end of this webinar. It's a long one. You're taking now existing or creating new applications, containerizing applications, and then creating microservices environment. And then throughout the cycle, you're doing continuous improvement and continuous delivery through DevOps. Okay. All right, so that's all the time that we have. But before we end this webinar, I'd like to give you a few reminders. You can still get your Azure free account by going to azure.com/free. Now, once you have entered your personal details, you can get $200 of credit that you can spend. This is free credit, by the way. Your credit card will not be charged. There's also available 12 months of popular free services, and there are 25 services that are always free. These are the services that are available that are going to be given to you for each month for an entire year. So you have access to 750 hours of Linux virtual machine compute, as well as 750 hours of Windows virtual machines, and so on and so forth. This is just a quick visualization of all of the other services that are available as part of the Azure free credits that you can use within the 12 months as your trial is still ongoing. Now, once you have exceeded the limits of all of the other services, that's the only time where your $200 credit becomes used. And once your $200 credit becomes close to zero, you will get a friendly email from Microsoft to remind you that your credit is low. So it will ask you whether you want to continue to use the service and this time charging your credit card, or you want to be connected to a local Microsoft partner who can then bill you so that you can continue using your Azure and as well as use the services of that partner to help you along your cloud journey, your Azure adoption. If you want to learn at your own pace, there is always Microsoft Learn. Um, it's a long URL, but remember this URL, aka.ms/learn. All of the learning courses that you would need to learn Azure from all the way from Azure fundamentals to Azure architecture, which are some of the advanced courses. Power BI courses are also here. Microsoft 365, Office 365, as well as Dynamics courses, and even Power BI and Power Apps. Everything that you need to learn to be able to use all of these tools and become experts, as well as preparing for certification exams, can be found on Microsoft Learn. And like I said, and let me emphasize this, these are all for free. All you need to have is a PC with an internet connection, a good set of earphones or headphones, and time. So make good use of the time that we have in order for us to upskill ourselves for what's needed to in this new world. And you can actually select the different training courses based on the roles that you have. So if you are, for example, aspiring to become a data scientist, click on the data science, select the data scientist in the drop down, and the Microsoft Learn will actually select the courses that is appropriate for the role that you want, all the way from basic all the way to the advanced courses. There's also a specific learning site just for you to become an AI expert. It's called aischool.microsoft.com. This is, for example, where you can go to learn the basics of AI, AI in the business context, how AI is used in government context, and also in different industries such as manufacturing, retail, financial services, and education. Not only that, but it also gives you technical training, free technical training on how to build, for example, AI applications that uses our chatbot capabilities, our cognitive services capabilities, and all of the cloud-based and cloud-powered AI capabilities, and even Azure machine learning you can learn from this site. And again, this is absolutely free. Complete documentation is on Microsoft Docs. So the Cloud Adoption Framework, for instance, is on the Microsoft Docs site. So just go to docs.microsoft.com, select Azure from the selection, and all of the documentation that you need is already there. This is going to be your new best friend if you start on your Azure journey, especially in the beginning. Combine this with Microsoft Learn. These are two very powerful resources to help you to help you get your technical skills to get your cloud journey going. All right, now we are at the end of our webinar. I think we are making good on time. This is the schedule of our next webinars, and you can see the URL there at the bottom where you can register for these webinars. If you're interested in any of these topics, please do visit the URL at the bottom and register there. It also includes links to the previous recordings of this webinar. So for example, if you miss parts or the entirety of this webinar, you can just go back to the this aka.ms URL and then listen to the webinar on demand. All right, now that's the time that we have for today. Thank you very much for spending what is close to an hour with us to understand the topic of today's webinar. If you like if you like these formats of learning, like on-demand webinars or live webinars, please do register to in our future webinars. And then if you have any questions, feel free to drop me a note at hhermida@microsoft.com. So once again, thank you very much for spending your hour with us, and I hope you've learned something new today. Thank you.